Using factors to solve quadratic expressions. Learning intention to solve quadratic equations by factorizing. Success criteria. I can identify when an equation is quadratic. I can factorize a quadratic expression into two brackets. I can use the zero product property to find the values of x. I can check my solutions by substituting them back into the original equation. Take the equation x squared minus 5x plus 6 is equal to 0. When x is equal to 2, x squared minus 5x plus 6 becomes 2 squared minus 5 times 2 plus 6. So we sub in 2 in place of both x's with brackets, which gives us 4 minus 10 plus 6, which gives us 0. When x is equal to 3, x squared minus 5x plus 6 becomes 3 squared minus 5 times 3 plus 6. So we sub in 3 in place of the x's with brackets, which gives us 9 minus 15 plus 6, which also gives us 0. So when x is equal to 2 or x is equal to 3 for this specific equation, both sides of the equation are 0. When this happens, we say that x equals 2 and x equals 3 are solutions or roots of the equation. So if you sub in a value into an equation in place of x and the result is 0, then whatever number you subbed into the equation in the first place is called a solution or the root of the equation. Solving a quadratic equation involves finding values of x which satisfy the equation, which means make the equation balance. When a quadratic equation is in the form of ax squared plus bx plus c is equal to 0, so a quadratic trinomial, so quadratic because squared is the highest power, 2 is the highest power, and trinomial because you have 3 terms equal to 0. So basically when you have an x squared and x, a constant, equals 0, we express the left-hand side as the product, which means multiply, of two linear factors. So basically we factorize and then solve the equation as shown in the following examples. Example 1. Solve the equation x squared minus 5x minus 14 is equal to 0. So if we were to solve a linear equation, we would say letters to the left, numbers to the right. But because we have a squared, we can't do that. So if there's a squared involved in an equation you're trying to solve, you bring everything to the left and you let it equal to 0. So everything is already on the left-hand side and equal to 0. So what we can do next is factorize and then solve. Or you could use the minus b formula. So I'm going to write down the equation x squared minus 5x minus 14 is equal to 0. I'm going to factorize first and then solve. So I'll bring down the x squared, bring down the minus 14, break the minus 5x up into two parts. This minus tells me that these signs here will be different. So one's a plus and one's a minus. I get the factors of 14. They are 1 and 14, 2 and 7. I'm going to choose 2 and 7 because 2x minus 7x gives me minus 5x. I factorize the first two terms. I get x multiplied by x plus 2. So x squared divided by x is x, and 2x divided by x is 2. I factorize the right two terms, and my highest common factor is minus 7. So minus 7x divided by minus 7 is x, and minus 14 divided by minus 7 is 2. My brackets match, so the first part of my answer is x plus 2, and then x plus 7 is going to be my other factor. Now, if this question had said factorize, I would be finished. This would be the end of my answer. If a question says factorize, you want to have brackets in your answer. But it didn't say factorize, it said solve the equation. So solve means find x, get x on its own. So we need to find what x is equal to. So we know that this is going to be equal to 0. So we're going to let each of the brackets equal 0, or each of the factors equal 0. So x plus 2 is equal to 0. So the 2 comes over the equal sign and becomes minus 2. So x is equal to minus 2. And then likewise, we let x minus 7 equal to 0. So the minus 7 comes over the equal sign, and we get x equal to positive 7. So solve the equation, x is equal to -2 and x is equal to 7. So these are known as the solutions of the equation or the roots of the equation. So if we were to draw out the graph, here is the curve, x squared minus 5x minus 14 is equal to 0. It's a quadratic equation, so it's a U-shaped graph. And we can see it crosses the x-axis at -2 and 7. So these are known as the roots of the equation. So if you solve an equation, the x values that you get at the end are known as the roots of the equation, and they are the two places where the quadratic equation will cross the x-axis. So this is the x-axis here, and this is the y-axis. And we can see that the curve is crossing the y-axis at -14. So that's what the constant is up here. So if we want to solve the equation using the box method or the array method, we draw out our boxes. So we have 4 boxes. So x squared goes into the first box. So x times x gives us x squared. So into our empty set of brackets, we're going to put x in the front of both brackets. And -14 goes in the back because -14 is our constant. So this minus, again, tells us we have different signs. So we're going to get the factors of 14. We're going to go with 2 and 7. Because -7x plus 2x gives us -5x. And then 2x divided by x is 2. And -7x divided by x is -7. And then -7 times 2 is -14. So -7 goes in the back of one of the brackets and +2 goes in the back of the other brackets. So now that we've factorized, we're going to solve. So we say x minus 7 is equal to 0 and x plus 2 is equal to 0. So x is equal to 7 and x equal to -2. And these are our solutions. So solve the equation, x squared minus 5x minus 14 is equal to 0. Our solutions are 7 and -2. So these are the solutions or the roots of the equation. Example 2. Solve the equation, x minus 4 multiplied by x plus 1 is equal to 0. So this time the equation is already factorized. So all we have to do is let each of the sets of brackets equal to 0 and then get the x's on their own. So we have x minus 4 is equal to 0. So x is equal to +4. And then we have x plus 1 is equal to 0. So x is equal to -1. So these are the solutions of the equation. And these are the roots of the equation. These are the two places where this equation or this curve would cross the x-axis. Example 3. Solve these equations. 2x squared minus 9x equals 0 and 4x squared minus 25 is equal to 0. Part 1. 2x squared minus 9x is equal to 0. So we're going to factorize first, and this time we'll use the HCF method, the highest common factor method. So x is our highest common factor, and then 2x squared divided by x is 2x. So 2x squared divided by x is 2x, and that goes into the bracket. And then minus 9x divided by x is -9. So minus 9x divided by x is -9, and that goes into the bracket. So factorizing, we get x multiplied by 2x minus 9. Now we weren't asked to factorize, we were asked to solve. So now we have to let each of the brackets equal to 0. So technically we can stick brackets around this x. So we're going to have x in one set of brackets and then 2x minus 9 in another. So straight away we can let x equal to 0. So that's one of our solutions. And then we're going to have 2x minus 9 is equal to 0. So now we have to get the x on its own. So because we have a linear equation here, so no squareds, we just have an x that's technically x to the power of 1. So this is why it's known as a linear equation. So now we can do letters to the left, numbers to the right, because when we're trying to solve a linear equation, that's how we can do it. So the -9 comes over the equal sign and becomes +9. And then we're going to divide by the number stuck onto the x, which is 2. So dividing both sides by 2, we get x equal to 9 over 2, which is 4.5. So here's our curve. So this is 2x squared minus 9x is equal to 0. So this is the equation here. And we can see that 0 is one of the roots. We can see that the curve is crossing the x-axis at 0. And the other root is 4.5. It's also crossing the x-axis at 4.5. Part 2. 4x squared minus 25 is equal to 0. So we have a minus, so that's the difference. 4 is a square number. X squared is a square number. And 25 is a square number. So we have the difference of two squares. So we're going to factorize using the difference of two squares. So we have two sets of brackets, one's a plus, one's a minus. So I'm going to get the square root of 4x squared. And the square root of 4x squared is 2x. So that's going to go in the front of both brackets. And then I'll get the square root of 25. And that's 5. So that's going to go in the back of both brackets. So I factorized. I have 2x plus 5 multiplied by 2x minus 5. But I wasn't asked to factorize. I was asked to solve, which means find x, get x on its own. So I'm going to let each set of brackets equal to 0. Before I do that, I'm just going to do my check. I'm going to multiply out the brackets and see do I get back to the start. So multiplying out my brackets. Yes, I get back to the start. So I know that I factorized correctly. So now I'm going to solve. So I have 2x plus 5 equal to 0. So this now is a linear equation. So I can do letters to the left, numbers to the right. So the 5 comes over the equal sign and becomes minus 5. And then I divide both sides by the number stuck onto the x, which is 2. So I get x equal to minus 5 over 2, or x is equal to minus 2.5. So then I let the other bracket equal to 0, 2x minus 5. I'm going to bring the minus 5 over the equal sign. It's going to become plus 5. So letters to the left, numbers to the right. Divide both sides by the number stuck onto the x, which is 2. So x equal to 5 over 2, or 2.5. So I was asked to solve the equation. Solve means find x, get x on its own. So the solutions are minus 2.5 and 2.5. And these are the roots of the equation. These are the places where the curve crosses the x-axis. So we can see at minus 2.5 there and at positive 2.5. These are the roots of the equation. We can also see that this curve is crossing the y-axis at minus 25, and that's the constant, minus 25. So the curve on the right is a parabola. It's the graph of y is equal to x squared minus 5x plus 6. Can you use the graph to solve the equation x squared minus 5x plus 6 is equal to 0? So if we have a look at the graph, we want to solve, which means find the roots of the equation. And we can see the roots are 2 and 3. These are the two places where the curve crosses the x-axis.